Hello friends, and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in finding the next right node of a given key. First, let us take an example. In this example, the right key for 2 is 6. For node 4, it is 5. And for nodes 10, 6 and 5, it is null. Now, let us see the algorithm which will assist us in finding the next right node of a given key. Let us also have a sample tree to test our algorithm. We will be using two queues for this and a level variable to store level. Also, let us assume that we have to find the next right node of node 4. So, k will be equal to 4. Qn will store node addresses and the other queue Ql will store node levels. In the next step, we push the root node which is 10 into Qn. Now we push level which is 0 into Ql. Next, we enter the while loop and dequeue a node from Qn and its level from Ql. So, node will point to 10 and level will be equal to 0. We check if node's data is equal to k. Since 10 is not equal to 4, we now enqueue left and right child of this node. So, 2, which is the left child of 10, is pushed into Qn. In the next step, we enqueue level plus 1 into Ql. So, 1 will be enqueued into Ql. Now, we enqueue the right child of node 10. So, 6 is enqueued into Qn. Also, level plus 1 is enqueued into Ql. So, 1 is enqueued into Ql. We continue with the while loop as Qn is not empty. Now, node will point to the front element of Qn and level will be equal to the front element of Ql. Next, we dequeue 2 from Qn and 1 from Ql. We check if node's value is equal to k. Since 2 is not equal to 4, we now pass the left and right child of node 2 along with their levels. So, first we push the left child of node 2 which is 8 into Qn. Now, we push level plus 1 into Ql. So, 1 plus 1 which is equal to 2 will be enqueued. Next, we enqueue the right child of node 2 into Qn and level plus 1 into Ql. Again, since Qn is not null, we continue with the while loop. Now, node will point to 6 as 6 is the front element in Qn. Also, level will be equal to 1 as the front element in Ql is 1. Now, we dequeue 6 and 1 from Qn and Ql respectively. Again, we check if node is equal to k. Since 6 is not equal to 4, we enqueue the left and right child of node 6. As the left child of 6 does not exist, nothing is enqueued. Also, the right child of 6 is 5. So, we enqueue 5 into Qn. Now, we push level plus 1 into Ql. So, 1 plus 1 equal to 2 is enqueued into Ql. Again, since Qn is not null, we continue with the outer while loop. Now, node will point to 8 and level will be equal to 2. Next, we will dequeue 8 and 2 from Qn and Ql respectively. Next, we check if node is equal to 4. Since it is false, we go on to push the left and right child of 8. Since both are null, nothing is enqueued and we continue with the outer while loop. Now, node will point to 4 and level will be equal to 2. We dequeue 4 and 2 from Qn and Ql. Next, we check if node is equal to 4. Since this condition is satisfied, we now check if there are no more items in queue or given node is the rightmost node of its level. Since both are false, we return the next item in Qn, which is 5. So 5 is the next right node of key, which was 4. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in our binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.